Hello viewers, in today's session we are going to discuss another important problem from integration, and in this session we are going to discuss this integral where we have minus infinity to infinity x raised to 4 divided by 1 plus x square raised to power 5, right? So here we'll see how we can evaluate this integral using some properties of definite integrals and using the concept of beta and gamma functions. So let us start. So let us first call this integral as I, right? So here, first of all, we are going to use this important property of definite integrals where the integrand is an even function, right? Suppose we have the integral, say, from minus a to a, and here we have f of x dx, then this integral is equal to 2 times the integral from 0 to a and f of x dx, provided this integrand, that is f of x, is an even function, right? So by definition of even function, we know that f of minus x should be equal to f of x. So this is the first property which we are going to use to write this integral I as 2 times 0 to infinity and x raised to 4 over 1 plus x square raised to 5 dx, because here the integrand is x raised to 4 over 1 plus x square raised to 5, and we can see that the integrand is an even function, because if we replace x by minus x in this function, then f of minus x is now equal to minus x raised to 4, and then we have 1 plus minus x square raised to 5, right? Now here we have minus x raised to 4, that is minus 1 square, that is minus 1 raised to 4 is plus 1. So we have simply x raised to 4 and minus 1 square is equal to plus 1. So here we have simply x square. So we have 1 plus x square raised to 5, and this is our function f of x. So f of minus x is equal to f of x, which suggests that the integrand is an even function, right? So the first step is to write this integral in this form. So now our next step is to convert this integral into a beta function, right? And here we are going to use these important results, that is the beta function, that is beta m comma n, is defined by this integral, that is 0 to infinity, and we have t raised to m minus 1 over 1 plus t raised to m plus n dt. So this is the definition of beta function, right? And moreover, here we'll also utilize this important result which connects the beta function and the gamma function, that is beta m comma n is given by gamma m gamma n divided by gamma m plus n, right? And we'll also make use of this result, that is gamma n plus 1 is equal to n factorial, and gamma n plus 1 is equal to n gamma n, right? So these are some important results from the theory of beta and gamma functions which are going to be used to solve this integral. and moreover here m and n are greater than 0, right? Okay, now let us once again come to this integral, and now we'll make use of the method of integration by substitution, right? So let us take x square is equal to some variable, say t. So here it is important to note that we'll make this substitution x square is equal to t, because then we'll have 1 plus t raised to 5, and here we have 1 plus t raised to m plus n, right? So x square is equal to t, which implies that x is equal to square root of t. Now let us differentiate x with respect to t. So dx over dt is equal to d by dt of square root of t, and the derivative of square root of t with respect to t is 1 over 2 times square root of t, right? So now we can write dx is equal to dt over 2 times square root of t. Now let us change the limits of integration, right? So here x varies from 0 to infinity, and in the original integral we have minus infinity to infinity, and we have changed this integral to this form by using this property. So here we have minus a to a, here we have minus infinity to infinity, right? So now when x is equal to 0, then the value of t can be calculated from this relation. So we have t is equal to 0 square, that is equal to 0. And when x is tending to infinity, then obviously t is equal to infinity square, that is t also tends to infinity. So now let us write this integral in terms of t. So we have I, and this is 2, and then we have 0 to infinity, the limits remains the same, and x raised to 4. X raised to 4 can be written as t square, and then we have 1 plus t raised to 5, and for dx we can write 1 over dt over 2 times square root of t. So now we can easily observe that this 2 and this 2 get cancelled, and we have 0 to infinity. Then we have here t square, and here we have t raised to half, right? So taking t raised to half to the numerator and applying the laws of exponents, so we have 2 minus half, and here we have in the denominator 1 plus t raised to 5, and here we have dt. So now this integral I is equal to 0 to infinity, and we have t raised to 2 minus half is 3 over 2, and we have 1 plus t raised to 5, and here we have dt. So now this integral is transformed into this one, and now this integral looks similar to this one, right? So if we compare this integral with this one, that is say 0 to infinity, and we have t raised to m minus 1 over 1 plus t raised to m plus n dt, then m minus 1 is equal to 3 by 2, and m plus n is equal to 5, right? So we have here two equations, and we can find out the values of m and n, and m is 3 by 2 plus 1, that is 5 over 2, and from here we can find out the value of n, that is 5 minus m. So we have 5 minus 5 by 2, that is 5 over 2, that is 2 times 5 is 10, 10 minus 5 is 5, that is 5 over 2. So now this integral I can now be written as 0 to infinity, and we have t raised to m minus 1. So m is 5 by 2. So here we can write 5 by 2 minus 1, and 1 plus t raised to m plus n. So m is 5 over 2, and n is also equal to 5 over 2, and here we have dt. So now the value of m is 5 by 2 and n is equal to 5 by 2, and by the definition of beta function, we have this integral I is equal to beta function, that is beta 5 by 2 comma 5 by 2. So let us find out the value of this expression, that is this beta function, by using this result. So now we can write I is equal to gamma 5 by 2. Then we have gamma 5 by 2, taking m is equal to 5 by 2 and n is equal to 5 by 2 in this expression. We have gamma 5 by 2 plus 5 by 2. So here we have gamma 5 by 2 square, and then here we have gamma 5, because 5 plus 5 is 10, 10 over 2 is 5, right? So now let us find out the value of gamma 5 by 2 using this relation. So we can now write gamma 3 by 2 plus 1. We can split 5 by 2 like this, and using this result, that is gamma n plus 1 is equal to n times gamma n. So we have 3 by 2 gamma 3 by 2, and again splitting 3 by 2 as half plus 1. So we have 3 by 2, and again using this result over here, so we have half gamma half, and gamma half is equal to square root of pi, right? So we have 3 over 4, and here we have square root of pi, and gamma 5 can be obtained by using this result. We can write gamma 5 as 4 plus 1, that is equal to 4 factorial, right? And 4 factorial is 4 times 3 times 2 times 1, that is equal to 24. So now the value of the integral I is equal to square of gamma 5 by 2, and we have 3 over 4 root pi, and here we have square, and gamma 5 is equal to 24. So this is 3 square is 9, 4 square is 16, and the square of root pi is simply pi, and in the denominator we have 24. So we can now here cancel this 9 and 24 by 3. So we have here 8. So this is 3 pi over 16 times 8, that is 3 pi over 128, right? So viewers, the value of this integral I is equal to 3 pi divided by 128. Hello viewers, in today's session we are going to discuss another important problem from integrals, and in this class we are going to evaluate this integral that is from 0 to 1, and we have x raised to 5 divided by the cube root of 1 minus x cube, right? So we'll evaluate this integral with the help of the concept of beta and gamma functions, right? And before applying the concept of beta and gamma functions, we'll make use of the method of substitution, right? So let us start. So here we'll try to convert this integral into a beta function which is defined by beta m comma n is equal to 0 to 1, and we have t raised to m minus 1, 1 minus t raised to n minus 1 dt, where m and n are greater than 0. So the purpose of applying the method of substitution is to convert or to reduce this integral into this form, right? So here let us first take this integral as I, and let us make this substitution, that is t is equal to x cube, so that we have x is equal to t raised to 1 over 3. Now let us differentiate x with respect to t to get the value of dx. So we have dx over dt, that is equal to d by dt of t raised to 1 over 3, and using the power rule here, that is d by dt of t raised to n is given by nt n minus 1. So we have 1 over 3 t raised to 1 over 3 minus 1. So we have 1 over 3 t raised to 1 minus 3 over 3, that is 1 over 3 t raised to minus 2 by 3. So we can now write dx is equal to 1 over 3 t raised to minus 2 by 3 dt. Now here the limits of integration vary from 0 to 1. So when x is equal to 0, which is the lower limit, the value of t can be obtained from this relation. So we have t is equal to 0 cube, that is 0. And when x is equal to 1, which is the upper limit, so we have t is equal to 1 cube, that is equal to 1, right? So now we can write this integral I in terms of t as 0 to 1. The limits remains the same, and x raised to 5. So x is t raised to 1 over 3. So we can now write 1 over 3 raised to 5, and then we have cube root of 1 minus t, and for dx we can now write 1 over 3 t raised to minus 2 by 3 and dt. So now let us simplify or rearrange this integrand, and we can take 1 over 3 outside the integral. We have 0 to 1 t raised to 5 over 3, and then we have here t raised to minus 2 by 3. So we can use the laws of exponents to add these two numbers. So we have plus minus 2 by 3, and in the denominator we can now write 1 minus t raised to that is 1 over 3, because this is cube root of 1 minus t, and here we have dt. So now I is equal to 1 over 3, 0 to 1, and t raised to this is 5 minus 2, 3, and 3 over 3 is 1. So here we have 1, and then we have 1 minus t raised to 1 over 3 dt. Now we can write 1 over 3, 0 to 1, t raised to 1, and we can take 1 minus t raised to 1 by 3 to the numerator. We have 1 minus t raised to minus 1 by 3, and here we have dt. So now we can write 1 over 3. Here we have 0 to 1, and t raised to 1 can be written as m minus 1. So we can write simply 2 minus 1, because 2 minus 1 is 1. And here we have minus 1 over 3, and minus 1 over 3 can be written as 2 by 3 minus 1. So now this integral is of this form, and here the exponents, that is 1 is equal to 2 minus 1, and minus 1 over 3 is 2 by 3 minus 1, because 2 by 3 minus 1 is 2 minus 3 over 3, that is minus 1 over 3. right? So now if we compare this integral with this one, then the value of m is 2, this is 2, and the value of n is 2 by 3, and obviously 2 and 2 by 3 are greater than 0. So we can now write I is equal to 1 over 3 beta function, that is beta of m comma n. M is 2 and n is 2 by 3. So now to get the value of beta 2 comma 2 by 3, will make use of this important result which connects the beta function with gamma function. So beta m comma n is given by gamma n divided by gamma m plus n. Now we can write here 1 over 3, and using this result we have gamma 2, then gamma 2 over 3 divided by gamma 2 plus 2 by 3. So the value of the integral I can now be written as 1 over 3. Now gamma 2 is given by simply 1, because we know that gamma n plus 1 is equal to n factorial, where n is a positive integer, right? So gamma 2 can be written as 1 plus 1, that is equal to 1 factorial, that is simply 1. So gamma 2 is equal to 1, and we'll keep this term as such, that is gamma 2 by 3, and in the denominator we have gamma 8 over 3, right? Now let us find out the value of gamma 8 over 3 using this result, that is gamma n plus 1 is equal to n times gamma n, right? So this is another important result. Gamma n plus 1 is equal to n times gamma n, where n is some fraction here. So we can now write here we have a positive fraction, that is 8 over 3. So 8 over 3 can be written as 5 over 3 plus 1, that is of the form gamma n plus 1. So here n is a positive fraction, that is 5 over 3. So we can apply this rule. So we have 5 over 3 gamma 5 over 3. Now further 5 over 3 can be written as 2 over 3 plus 1. Now again this term is similar to this one, n plus 1, and again n is a positive fraction, that is 2 by 3. So we have 5 over 3, and applying this rule we have 2 over 3 gamma 2 over 3, right? So this is 5 times 2 is 10, 3 times 3 is 9, and gamma 2 over 3. So now substituting this value of gamma 8 over 3 as 10 over 3 times gamma 2 over 3 in this expression, I is now equal to 1 over 3. This is 1, and we have simply gamma 2 over 3, and this is 10 over 9 gamma 2 over 3. Now these two terms get cancelled, and we are left with 1 over 3 times here we have in the denominator 10 over 3. So taking 9 to the numerator, we have 9 over 10. So this is 3 times 3, 9, that is 3 over 10. So viewers, the value of this integral I is equal to 3 over 10, which can also be written as 0.3. So the value of this integral is 0.3 or 3 over 10.